A very special good afternoon to all my lovely children. Welcome to Tripura Virtual Interactive Class. I hope you all are good, fit and fine and came with full of energy, as today's maths class also going to be very special like every time. So without any delay, let's start today's class. So my lovely children, I hope all of you remember what you have studied in our last class. We are continuing quadrilaterals. So today also we are going to start where we have ended in our last class. Before that, let's start with one simple question. Let's see how many of you are able to answer this question. Then we are going to proceed further. So the question is, one of the diagonals of a rectangle measures 4 centimeter. What is the length of the other diagonal? It's a very simple question. I hope all of you are able to answer. The options are 2 centimeter, 8 centimeter, 4 centimeter and 16 centimeter. So I am giving you time. All of you try to answer this question. Very easy question. The relation between the diagonals of a rectangle, I hope all of you remember. What would be the answer of this question? All of you try. And your time is almost up. I hope all of you give the correct option. Yes, your time is up. I am showing you the answer. Option C is the correct option. Because we know the diagonals of a rectangles are equal in measure. So one diagonal is 4 centimeter given. That means the other diagonal also 4 centimeter. Yes. So let's move further. Now a carpenter's problem. Let's see one carpenter's problem. For the quadrilateral to be a rectangle, we need to answer the following questions. So what is the question? What is the length of the other diagonal? What is the point of intersection of the two diagonals? Okay. The carpenter has to take two equal strips of wood. Okay, the carpenter uses two equal strips of wood and tries to get a triangle by passing a thread through their endpoints. Okay, so here you see two equal strips of wood that carpenter took, and what he did, he tries to get a rectangle by passing a thread through their endpoints. So is it looking like a rectangle? What you think? No, it is not looking like a rectangle. Okay. A rectangle is not formed. That means rectangle not formed. So then how the diagonal should intersect? So now question is coming, how this diagonal should intersect so that when you join all these corner points with the thread, it will look like a rectangle. What would be the meeting point of the diagonal? Is there any special meeting point, or anyhow we can meet these two strip of woods? Whether we can give the meeting at any point, or there are some particular place where both the diagonals will intersect to make it look like a rectangle. So let's see. Here this diagram is the diagram of a rectangle, we know. Yes. O seems to be the midpoint of a. So in your screen you can see, you see how O is looking like. Can you tell? Yes, it is looking like O is lying in between of AC and BD, right? It is the midpoint of AC line as well as BD line. Okay. By applying a logic, let's confirm that the diagonals of a rectangle intersect at the midpoint. So see, this is a rectangle and their meeting point, the diagonals meeting point, looking like it is the midpoint. Meeting point is looking like the midpoint. Now by applying logic, it is to looking like, whether actually it is the midpoint or not, by applying logic, let's confirm this thing, whether rectangle intersect at their midpoint or not. So let's see. Okay, here one rectangle ABCD is there and we join the diagonals AC and BD, and the meeting point we gave name as O. O is the midpoint of O is the intersection of the diagonals AC and BD. Now, if we consider two triangles, one triangle is triangle AOD, this one. Another triangle, triangle COB, this one. These are the two triangles, okay. Now, here you can see one triangle AOD, another one is COB, okay. You can see two angles, right? One is angle AOD, another one is angle BOC. Angle AOD is equal to angle BOC. Why? Can you tell me why? Yes, very good, because both are vertically opposite angles. Yes. So you all are correct because these angles are vertically opposite. Okay. Now another one you see, this is angle 1. Can you tell the full name of angle 1? Yes, very good. Angle DAO. We can say angle DAO or OAD. Similarly, angle 2. What can be the other names of angle 2? We can call it as angle BCO or angle OCB. This one also we can call. Yes. Now again you see, this is angle 3. Angle OAB is angle 3 and this line AD and AB. Here you see angle 1 equals to what we can write? 90 degree minus 3, angle 3. Why? Because what we know, a rectangle having all the angles are 90 degree. So as this A angle full is 90 degree, that means if you subtract from 90 degree to angle 3, what will you left? You will left with angle 1. So that's why we can write it like this. Angle 1 is equal to 90 degree minus angle 3. So this is equation 1 we can say. Now here you see another triangle is there. Triangle ABC. Again angle B is how much? 90 degree we know. Okay. So that means what? Angle 3 plus angle 2 plus 90 degree. Can you tell what would be the value of these three angles? Yes, very good. The angle sum will be 180 degree. Why? Because these three angles sum representing the sum of the all angles of a triangle. And what we know, the sum of all angles of a triangle is always 180 degree. So here you see the triangle is triangle ABC. So in triangle ABC, angle 3, angle 2 and 90 degree, all together if you add, the answer will be 180 degree. That means angle 3 plus angle 2 if you take, that means 180 minus 90. So if you subtract 90, what is the value of 3 plus 2? Angle 3 plus angle 2 is coming 90 degree. That means what we can say? Angle 2 is equal to 90 degree minus angle 3. See, angle 2 is equal to 90 degree minus angle 3. Okay. So this is another equation. Now you see angle 1 value came 90 degree minus 3. Angle 2 value came also 90 degree minus 3. So now if you compare both, are not they equal? Angle 1 and angle 2. This angle 1, whatever the value, what is the value? 90 minus angle 3. Similarly, the value of angle 2 also what? This is also same. This is also 90 minus 3. Yes. So from here, what we can conclude? Angle 1 is equal to angle 2 we can conclude. Okay. So this is another one. So again we back to our main position. That means for triangle AOD and triangle COB, these are our required triangles. So what we are doing? First we saw these triangles are vertically opposite. Then we saw angle 1 is equals to angle 2. Okay. Now what we know? A rectangle having opposite sides are parallel and equal. So that means AD and BC are equal in length. So we can write AD equals to BC. Okay. Now here you see two angles are matching and one side is matching. That means by AAS congruence rule, what we can tell? Both the triangles are congruent triangle. So, by corresponding parts of congruent triangle, what we can conclude? Why we are proving that this one is congruent triangle? What is the necessity? Now you see by CPCT, we can say that DO is equals to OB because these are the corresponding parts. Also, AO equals to OC. That one also we can say. These are also by CPCT, corresponding parts of the congruent triangle. So that means DO equals to OB as well as AO equals to OC. Okay. That means from here, what we can conclude? The diagonals of a rectangle always intersect at their midpoints. Right. That means what? Diagonals always intersect at the midpoints. Yes. So when the diagonals intersect at their midpoints, we say that they bisect each other. So when they meet at the midpoints, that means what? Diagonals are bisecting each other. Bisecting a quantity means dividing it into two equal parts. Anything bisecting means what? Suppose here I draw one line and another line I am showing you with yellow color. Yellow color line bisect the given red color line. Means what? Means this red line became equal to parts. So that's why bisecting means what? Bisecting a quantity means dividing it into two equal parts. Okay. One assignment for you all. So construct few triangles, draw its diagonals and verify if they bisect each other. So that one you have to do. You have to construct few triangles and you have to tell. Okay. Now here in Carpenter's problem, let's see again. What is the point of intersection of two diagonals? What would be your answer now? The carpenter has to arrange two strips of wood so that they bisect each other. That means what? How he have to arrange those diagonals? So both the wood should be equal in length. And next, if you make it the diagonal, that means what? The carpenter has to arrange two strips of wood so that they bisect each other. It's supposed to bisect each other. Okay. Okay. Now again, what he is doing? He took the two equal strip of woods and arranged them such that they bisect each other. Okay. He takes equal diagonals and mark their midpoints. Okay. First he took the strips and then he marked their midpoints with the scale. Okay, suppose this one is the midpoint and here also this blue dot is the midpoint. Okay. Now he makes the diagonals to intersect at their midpoints. Now what he did? He make it in such a way so that they intersect each other at the midpoint. Okay, so he put it like this. Now he joins the endpoints of diagonals using a thread like the previous one. Previously also it was not midpoint. He just intersected both the woods and then he joined with a thread and saw that the shape was not looking like a rectangle, right? But this time, as we saw, rectangles diagonal intersect each other at midpoint. That carpenter also, what he did, he took the midpoint of the strips and then he intersected both the midpoints and then he again joined those with a thread. Okay. So after joining, now he got the rectangle. You see, this is the shape of the rectangle. Okay. The carpenter's problem shows that rectangles can also be defined as follows. So how we can define? A rectangle is a quadrilateral whose diagonals are equal and bisect each other. So from the carpenter problem, what we got to know? We got to know that a rectangle we can define in such a way that this rectangle is a special type of quadrilateral whose diagonals will be equal in length. Also, when they will intersect each other, that intersection point should be the midpoint of the diagonals. Okay, now let's see some properties of rectangles. So ABCD is a rectangle. One number property is each of the angles is equal to 90 degree. That one we know. And this one also 90, B value, this is also 90, C 90, D also 90. That one all of us know. Okay. Next, two number is opposite sides are equal. The opposite sides AB is equal to DC, AD is equal to BC. Okay. Next, diagonals are equal. Diagonals are equal. That one only just now we saw by the carpenter's problem. Also what we saw, diagonals bisect each other. So these are the properties of rectangle. Let's measure the angle of intersection of diagonals. So let's see, let's measure the angle of intersection of the diagonals. Okay, so when you are measuring, what you can see, when you are measuring, it is almost equal to 60, right? Okay, the angle of intersection of the diagonals is 60 degree, you can saw. Yes. What happens if the carpenter changes the angle of intersection of the diagonals? Will he still get a rectangle? So again they are asking, what will happen if he change this angle? If he change the angle now, previously what he saw, it was 60 degree. Now what will happen, they are asking. Suppose he intersected both the strips in midpoints, but now he changed the angle. It was 60 degree, now he changed the angle. Now what will happen? Will it still a rectangle or it will be something else? Now see, this time how much? It is showing towards 40 degree. So now the angle became 40 degree. Now what will happen? Let's see. Again, if we join this with a thread, then again it is looking like a rectangle. That means what? From here, what you can conclude? If you change the angle of intersection, then also still it will be a rectangle. The condition only impose on what? The diagonal should be equal in length. Also, they should bisect each other. This is the condition. Okay. Again you see, he changed the angle again. He make it 70 degree instead of 60 again. It was 60, that time also same. When it was 40, that time also same. Again when it is 70, that time also still a rectangle we are getting. Yes. Okay. Now one question time for you all. Let's see how many of you are able to answer the question. The question is, identify the incorrect statement about rectangle. Okay, you have to find the incorrect statement. The options are, option A, each angle measures 90 degree. Option B, opposite sides are equal. Option C, diagonals are equal. Option D, diagonals do not bisect each other. So let's see how many of you are able to answer the question. I give you time for 30 seconds. Let's see how many of you are able to answer the question. It's a very easy one. Just now we saw all the properties of a rectangle. So here, out of these four, which one you think that it is not correct? This is not the correct option. So which one is your answer? Your time is almost up. Okay, here I am stopping the timer. I am showing you the answer. The answer is option D. Diagonals do not bisect each other. But what we know? For a rectangle, diagonals must bisect each other. That one we know. Yes. Okay. Now they are asking what happens if the angle of intersection of the diagonal is 90 degree. So what will happen if the intersection is 90 degree? So let's see. Now again you join all the corner points with a thread. Now can you guess the shape of this? Is it still a rectangle or it is a special type of rectangle? What do you think? How it is looking like? This quadrilateral looks like a square now. Yes. Let's measure the length of its sides and interior angles to confirm whether it is a square or not. So as it is looking like square, so let's confirm it whether it is a square or not. Okay, so when we are measuring all the sides, you see it came 5.6. Okay, another side, this one also came 5.6, another side, this one also came 5.6, another side also 5.6. Okay, that means all sides are equal. Now again we are having two conditions. It can be a square or it can be a rhombus. So let's see what we know. A. Okay, so what you can see from here, what is the value of the angle? It is 90 degree in length. Okay, so what we know? Any quadrilateral to become a square, the angle should be what? Angle should be 90 degree. So here you see the angle is 90 degree. All angle measures 90, 90, 90 and all sides are equal in length. That means we are confirmed that what? This is a square. Yes. So from here what we conclude? So the diagonals, if diagonals are equal and if the bisection of the diagonals, the center angle is equal to 90 degree, that time the special type of rectangle whatever will form, it will be a square always. Okay, so this is a square. Does square satisfy all the properties of rectangle that we discussed? Let's check. Okay, let's check. In a rectangle, what we have, what we should have, each of the angles must be equal to 90. Yes, we got all the angles 90 degree in square also. Okay, two number opposite sides must be equal. Yes, in a square also opposite sides are equal. Option 3, diagonals must be equal. Yes, in square also diagonals are equal. Option D, diagonals must bisect each other. Yes, diagonals are bisecting each other. That means all the properties of rectangle, this square is fulfilling. So that means it is the speciality of square is all sides are equal actually. The square satisfy all the property of rectangle. That means what we can say? Square is a special type of rectangle we can say. Okay, note it down. A square is a special type of rectangle whose sides are equal. Every square is rectangle, but clearly every rectangle is not a square. So which rectangles will not be a square? If I ask you, what would be your answer? Yes, very good. The rectangles whose center angles are not equal to 90 degree, those rectangles are not square. One rectangle to be a square, the center angle must be 90 degree. Yes. Okay. Now let's see. Okay, rectangle, this is a rectangle, this is a square. The intersection of diagonals need not be 90 degree, and in square the angle of intersection of diagonals is equal to 90 degree. Opposite sides equal, all sides equal. Okay, so this one we know. Now another question time for you all. Let's see how many of you are able to answer. The diagonals of a square intersect at. What is your answer? All of you try to give the answer. I am giving you 30 seconds time. All of you try to answer. Very easy question. The diagonals of a square intersect at. Option A 90 degree, option B 45 degree, option C 60 degree or option D 30 degree. What is the correct option you think? All of you try to answer. Your time is almost. Here I am stopping the timer. I am showing you the answer. Yes, very good. You all are correct. Option A is the correct option. Okay, so here are the diagrams of rectangle and square. We know that opposite sides of these shapes are parallel. All of you know, in rectangle also opposite sides are parallel. In square also opposite sides are parallel. Equal is also there, but what we know, these are parallel also. Okay, here you can see. Do you think only rectangles and squares can have opposite sides parallel? So what do you think? Can you tell that only rectangle and square having opposite sides parallel, or there are some more shapes in quadrilateral whose opposite side can be parallel? Let's see. Okay, so let's see. Now see, previously the rectangle angle was 90 degree. Now if you make it little bit tilt, then what will happen? These are the quadrilaterals with opposite sides parallel but not rectangle. Why? Because these angles now not equal to 90 degree, it is less than 90. 90 was when it was 90, when it the side was in this position, that time it was 90, but now see it became bend little bit, this side inclined. So due to the inclination, this angle not 90 degree now. Okay, same for the case of square also. When it was 90 degree, the position of the side was here, but now due to the inclination, the angle is not 90 degree right now. Okay, so these are called what? These are having some special name. You can see opposite sides still now parallel to each other. You can see opposite sides are parallel to each other, but no angle is 90 degree now. That means we can't tell that these are rectangle or square. So what is the name of this shape? These are called parallelogram. So let's define a parallelogram. A parallelogram is a quadrilateral in which both pair of opposite sides are parallel. That means how we can define a parallelogram? A parallelogram is a quadrilateral in which both pair of opposite sides are parallel to each other. So this is a parallelogram. Okay, so you can see the parallelogram. Okay, so parallelogram, rectangle. So what is the difference between them? Rectangle is a parallelogram with all its angles equal to 90 degrees. It is not like that. If angle will, it will not be parallelogram. It is still a parallelogram. Why? Because all the properties of parallelogram, rectangle, how? The parallelogram definition is what? All the opposite sides must be parallel to each other. You can see in the case of, you can see these two are opposite sides and both are parallel. Similarly, these two are opposite sides and these two are also parallel. That means rectangle type of parallelogram, but all parallelograms are not rectangle. Why? Because all parallelogram doesn't have all angles equal to 90 degree. If all angles equal to 90 degree, then also a parallelogram. If all angles not equal to 90 degree, then also a parallelogram if opposite sides are parallel. But in case of rectangle, if opposite sides are parallel, this is not the enough condition to call it a rectangle. What is the another and most important? The angles will be equal to, then only it will be a rectangle. Okay. Now you can see one parallelogram in your screen. Okay, it is a square. It became square now. Similarly, like rectangle only, for square also, if it is inclined when angle is not 90 degree, that time also it is a parallelogram. Again, when it was 90 degree and it is looking like a square, that time also it is a parallelogram. That means from here what we can tell? Every rectangle and every square is a parallelogram. Yes, we can tell. I hope this much is clear. From here what we can conclude? Every rectangle and every square is a parallelogram actually. Okay. Is every parallelogram is a rectangle? Now if I ask you, every parallelogram need not be a rectangle square. Why? Because all the angles are not equal, not necessary to be 90 degree to become a parallelogram. So as angles are not 90 degree, that means so it is not a square, not a rectangle. So that means all parallelograms need not be a rectangle or square. Okay, every square is a rectangle. Can you tell every square is a rectangle? Yes, we can tell. Okay, every rectangle is a parallelogram. Can we tell every rectangle is a parallelogram? Yes, we can tell. Okay, here is one question time for you all. Let's see how many of you are able to answer this question. Choose the correct statement. So they are asking you to choose the correct statement. The questions are option A. The options are every square is a rectangle, every rectangle is a parallelogram. Both A and B correct, both A and B are incorrect. So I am giving you 30 seconds time. All of you try to answer this question. You have to choose the correct statement. Whether every square is a rectangle, if it is correct, yes. Next, B number. Every rectangle is a parallelogram. Whether it is yes or no, you check. Okay, if you think both are correct statement, then you have to choose option C. That means both A and B are correct. And if you think both are wrong, that means you have to choose option D. That means both A and B are incorrect. Okay, your time is up. I am showing you the result. The result is option C. Option C is the correct option. Both A and B are correct. Why? Because we know every square is a rectangle, because all the properties of rectangle square can fulfill, and every rectangle is a parallelogram. This is also true because all the properties of parallelogram one rectangle can fulfill. So that means as both the statements are correct, we can choose option C, both A and C. Okay, now they are asking you construct a parallelogram with adjacent sides of length 5 centimeter and 6 centimeter and angle of 60 degree. So let's try to draw a line segment AB of 5 centimeter. So at first you draw a line segment of 5 centimeter. Okay. After that you give it name AB and write it down as 5 centimeter. Make an angle of 60 degree from point A using a protractor. Can you put a protractor on A point and check where is 60 degree. You check your protractor where is 60 degree. So where is 60 degree? You see here is the 60 degree point. So after that with protractor you give the 60 degree point, mark the 60 degree point and join with the scale. Draw a line from A passing through the mark point. So you draw the line, join the line from A to that point. Okay. So after that, what you have to do? Mark the length 6 centimeter from the point A and name it as D. So from point A, you check that 6 centimeter, you cut it and then give the name of this point as D. So this is AD is how much? AD is 6 centimeter. Mark the same length from the point B also. From point B also you mark the same thing. Same distance you collect and that side you give one cut. Draw an arc from D point that has the same length of AB and name the intersected point as C. Now they are telling you to take the measure of AB and from D you cut that one, the previous arc. So if you cut the previous arc, they will meet at a point and they are telling you to name it as C. Okay. After that you have to join DC and BC. So all of you join DC and BC. So if you join these two, what you are getting? You can see that BC is 6 centimeter. Similarly, AB is 5 centimeter. You can see. Yes, that means it is a parallelogram. Okay, here one question time for you all. Let's see how many of you are able to answer. The question is, in a parallelogram HOME, HO is 6 centimeter, OM is 4 centimeter. What is the length of ME? All of you try to answer. I am giving you timer. What is the value of ME? Very easy. Just now we saw a parallelogram having opposite sides are equal. So what would be your answer? Yes, I am stopping the timer because this is very easy. Option D is the correct option because opposite sides are equal in a parallelogram. So as HO is 6, EM is also 6. Similarly, MO is 4. EH also 4. Okay, I hope this much is clear up for everyone. Okay, so we are going to continue in our next class from here. So till now, this much, all of you prepare well at home and meet me in next class. Till now, bye bye.